In this section, we will learn about how to solve trigonometric equations. Let's learn through examples. Find all solutions of the given equation. If you cannot find the exact answer, then round to 2 decimal places. First problem is cosine of theta plus 1 equals 0. General process will be we will solve for the trigonometric function. In this case, we have cosine. To get cosine of theta by itself on the left side, we will subtract 1 on both sides. Then we have to decide what method we have to use. In this case, cosine of theta is the minimum value of the cosine function. So we have to figure out where that happens by drawing the cosine function's graph. It's enough to consider up to 2 pi because after you think about the solution between 0 and 2 pi, you will extend the solution by adding 2k pi, meaning you have to list all the coterminal angles. This is pi over 2. This is pi. This is 3 pi over 2. This is y equals cosine of x or cosine of theta. Cosine of theta is minus 1 at pi. Between 0 and pi, we have only one solution. That solution is pi. Then we look at the problem. The problem asks you to find all solutions, which means all coterminal angles will be the solution. So multiple of 2 pi will be coterminal angles. So the final answer will be pi plus 2 pi k when k is an integer. This time, the problem is square root of 2 sine of theta plus 1 equals 0. Let's get sine of theta by itself on the left side. To do that, we will subtract 1 on both sides. Then on the left side, we have square root of 2 times sine of theta equals minus 1. Then we divide by square root of 2 on both sides. So sine of theta equals minus 1 over square root of 2. So when we think about the triangle, that is related to 45, 45, 90-degree triangle. In this problem, we have to use Radian mode, so we will put that as pi over 4. Then we have to identify the solution between 0 and 2 pi. To do that, the first thing we have to think about is whether the sine value is positive or negative. That is negative. So the angle will be in either third quadrant or fourth quadrant because y values are negative in the third and fourth quadrant. So sine values are negative. This is a reference triangle. So this is the reference angle. Of theta. So we will locate the angle in the third and fourth quadrant with reference angle pi over 4. This is pi. We can rewrite that as 4 pi over 4 because we think about the fraction with denominator 4. Then we will convert that into the given angles to the angle between 0 and 2 pi. Then in this case, that is pi plus pi over 4. Let me write down pi plus pi over 4. So that is 4 pi over 4 plus pi over 4. So that is 5 pi over 4. This is one answer between 0 and 2 pi. The other answer will be from this angle. In this case, it is better to think about this angle. This is 0 or 2 pi. 2 pi can be written as 8 pi over 4. That is pi over 4 less than 8 pi over 4. So this one will be 7 pi over 4. Coming from 8 pi over 4 minus pi over 4. Now we obtained two answers between 0 and 2 pi. Those are 5 pi over 4 and 7 pi over 4. We have to list all solutions, so we have to add 2 pi k for all the coterminal angles. Next question is about square root of 3 cotangent of theta plus 1 equals 0. Let's solve for cotangent of theta. To do that, we will subtract 1 on both sides. Then we get square root of 3 cotangent of theta equals minus 1. And then we divide by square root of 3 on both sides. So cotangent of theta equals minus 1 over square root of 3. From this information, we notice that cotangent is less than 0. And we have to identify the reference triangle. Reference triangle is obviously 30, 60, 90 degree triangle. We are thinking about cotangent, so 1 is adjacent and square root of 3 is opposite. So square root of 3 is opposite and 1 is adjacent to the angle pi over 3. This pi over 3 is the reference angle. Let's locate the angle on the quadrant to identify the solution between 0 and 2 pi. Cotangent is defined as x over y in the quadrant, in the coordinate form of the definition. So in the second quadrant, x is minus, y is plus, so that is less than 0. And in the fourth quadrant, cotangent of theta equals x is positive and y is negative, so it's again less than 0. Otherwise, plus over plus or minus over minus in the third quadrant, so the angle will be located either in the second quadrant or fourth quadrant. We already identified the reference angle. Reference angle was pi over 3. This is pi over 3. This is again pi over 3. We want to calculate the actual angle. This is pi. This can be written as 3 pi over 3. This angle is 0 or 2 pi, which can be written as 6 pi over 3. So this angle is 2 pi over 3 from 3 pi over 3 minus reference angle pi over 3. And this angle is 5 pi over 3 from 6 pi over 3 minus pi over 3. So if we write the solution as we have been doing, then we can write 2 pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. However, if you look at the angle relationship between this angle and this angle, then the difference between 2 pi and 5 pi is pi. So let me rewrite this. 2 pi over 3 plus 5 pi, 3 pi over 3, which is, this is pi. Then that is 5 pi over 3. So this amount is pi amount. So instead of writing the answer in this way, you can combine the answer so that the final answer becomes simpler. So instead of adding 2 pi, you can add pi. So 2 pi over 3 plus pi times k when k is an integer. Then when you add pi, you will get 5 pi over 3, and so it covers all the angles. The format of the answer, you have to follow the instruction in WebAssign. If there is no other specific instruction about the answer format, then I believe both will be accepted. The next problem is tangent of theta times sine of theta plus sine of theta equals 0. In both terms, we have sine of theta, so we can take out sine of theta. So we are taking sine of theta, so tangent of theta plus 1 times sine of theta equals 0. Two numbers are multiplied and became 0. That means either this component is 0 or this component is 0. So tangent of theta plus 1 equals 0, or sine of theta equals 0. Let's work out both cases. Tangent of theta equals plus 1 equals 0. If we solve for tangent, then it becomes tangent of theta equals minus 1. Obviously, the reference triangle will be 45, 45, 90-degree triangle. This is pi over 4. And tangent is less than 0, so that'll be either second quadrant or fourth quadrant. You can just do your reasoning by applying y over x definition. So one angle is located in the second quadrant and the other one is located in the fourth quadrant. The reference angle is pi over 4. Let's calculate the angle. This angle is 3 pi over 4 because from 4 pi over 4 minus pi over 4. And this angle is, this can be regarded as 2 pi. That is 8 pi over 4. So this angle is 7 pi over 4. We have two angles. When we think about the difference between 3 pi over 4 and 7 pi over 4, the difference is 4 pi over 4, which is plus pi. What I'm saying is in the angle ranges between 0 and 2 pi, we have two answers, 3 pi over 4 and 7 pi over 4. However, 7 pi over 4 can be obtained by adding pi to 3 pi over 4. So instead of writing down two answers with coterminal angle expression plus 2 pi k, we will write 3 pi over 4 plus pi times k That is the solution for the first one. And the second one is about sine of theta equals to 0. There is no such associated triangle in this case, so we have to think about the graph of sine. If we think about the graph of sine, sine is 0 every pi. So we can easily say that theta is pi times k. The next problem is 4 times cosine squared minus 1 equals 0. Let's solve for cosine squared. Then we have 4 cosine squared of theta equals 1. We divide by 4 on both sides. Then cosine squared of theta equals 1/4. So if we square root on both sides, then cosine of theta is 1/2, or cosine of theta equals minus 1/2. So we have two cases. So we will work out one by one. Cosine of theta equals 1/2. In this case, the angle is positive. The associated triangle is 30, 60, 90-degree triangle because 1 and 2 are involved. 1 is adjacent because we are thinking about cosine, adjacent to pi over 3. So pi over 3 is the reference angle. We will combine these two information to locate that in the quadrant. Sine of cosine is determined by the x value. X values are positive in the first quadrant and fourth quadrant. So angle should be located either in the first or fourth quadrant with the reference angle pi over 3. So this angle is 6 pi over 3, which is 5 pi over 3. So we have two solutions between 0 and 2 pi. Those are 3 pi over 3 and 5 pi over 3. So we will generalize the answer to list all the answers. So that is pi over 3 plus 2 pi k and 5 pi over 3 plus 2k, 2 pi k. When cosine value is negative, the reference angle will be the same, but the angle location will be different. In this case, cosine value is negative, so when we locate the angle will be located in either second or third quadrant because x values are negative in the second and third quadrant. We already calculated the reference angle, those were pi over 3. This is pi, that is 3 pi over 3. So this amount will be 2 pi over 3. That comes from 3 pi over 3 minus pi over 3. For this angle, you will have 4 pi over 3 from 3 pi over 3 plus pi over 3. We got two angles for this problem. Those are 2 pi over 3 and 4 pi over 3. So generalized answer will be 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k. So we are having 4 solutions for this problem. Those are these two and these two. So when you write the answer, you can write pi over 3 plus 2 pi k and 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. That is a perfect answer, but if you want to simplify further, then you can combine these two by noticing 4 pi over 3 equals pi over 3 plus 3 pi over 3, meaning pi over 3 plus pi. So if we combine these two, then you can just write 3 pi, pi over 3 plus pi times k. And the other solution, maybe if you think about the difference, then you can say 5 pi over 3 equals 2 pi over 3 plus 3 pi over 3, which is 2 pi over 3 plus pi. So you can combine these two answers to write 2 pi over 3 plus pi times k. You can list 4 answers, or you can list the equivalent answer with 2 algebraic expressions. It's up to you. The next problem is 2 times cosine squared of theta minus cosine of theta minus 1 equals 0. This uses the quadratic equation. To know the pattern, we will put x equals cosine of theta. The cosine squared of theta equals cosine of theta times cosine of theta. So that is x times x, which is x squared. So the given equation can be rewritten as 2 times x squared minus x minus 1 equals 0. Our proposal will be, we will factor this and then we will solve the equation for 2 linear factors. You already know how to factor this type of polynomial, but let me introduce you my favorite method. I will list 2 numbers whose multiplication becomes 2, and I will list 2 numbers whose multiplication becomes 1. Then I will do cross multiplication. Then this is 2 and this is 1. 1 times 1 will be 2. What we notice is 1 times 1 is 1, but there is negative sign here. So the 1 of 1 should be negative 1. To determine that, what we will do will be, we will put either negative sign either to 1 or negative 1. If we put negative sign to 2, then when we add vertically, that will become minus 1. So our purpose is we make the number right in front of x. This equation can be rewritten as 2x squared plus minus 1 times x minus 1 equals 0. What we were doing was making the number in front of x by putting negative to either 1 or 2. After we determine which number should have negative sign, we transfer that negative sign to the number adjacent to that number. So we have this chart. Then what I will do, I will put x to the first numbers. Then the factorization will go 2x plus 1 times x minus 1 equals 0. So from here, we get two linear equations. So we have 2x plus 1 equals 0, or x minus 1 equals 0. We solve for x, then we have 2x equals minus 1. So x equals minus 1/2. For this one, x equals 1. However, we were thinking about the equation of cosine. X was cosine. So we replace x by cosine. So cosine of theta equals minus 1 over 2, or cosine of theta equals 1. As soon as you get to here, the problem is not different from any other problems. Let's do case by case. If cosine of theta equals minus 1, minus 1 over 2, then we will relate that with 30, 60, 90-degree triangle. 1 is adjacent, and the reference angle is pi over 3. In cosine of theta equals minus 1 over 2, that is less than 0. So x value is less than 0. Meaning the angle will be located either in second or third quadrant. Then we will locate the angle with reference angle pi over 3. So this angle is 2 pi over 3. And this angle is 4 pi over 3. So we have two answers from here. So 2 pi over 3 plus 2k pi, or 4 pi over 3 plus 2k pi. It doesn't matter whether you write k first or pi first. We get two answers from cosine of theta equals minus 1/2. Then the next one, if cosine of theta equals 1, 1 is the maximum value of the cosine function, so we have to figure out the angles by drawing the graph of the cosine. This is the graph of cosine. cosine is 1 when the angle value is 0, 2 pi, 4 pi, and so on. From here, we get 2k pi. In this problem, we have 3 answers. Let's do the next problem. The next problem is sine squared of theta equals 4 minus 2 cosine squared of theta. The differences between this problem and the previous problems is in this problem, sine and cosine appear together. However, if we use Pythagorean formula, then you can convert the equation, either the equation of sine function or the equation of cosine function. Pythagorean formula was sine squared of theta plus cosine squared of theta equals 1. Let's choose to convert the equation into the equation of sines. To do that, we solve for cosine squared, then we have 1 minus sine squared of theta. To convert the equation into the equation of sine functions, we will replace cosine squared by 1 minus sine squared. So the right side will be 4 minus 2, open parenthesis, 1 minus sine squared of theta. Let's simplify. Sine squared of theta equals 4 minus 2, minus minus will be plus, plus 2, sine squared of theta. Let's move 2 sine squared of theta to the left side. Then we have minus 2 sine squared of theta equals 4 minus 2, which is 2. The minus sine squared of theta is 2. That implies sine squared of theta equals minus 2. This is impossible. The reason is this is the number squared. That is always positive, but this number is negative. That cannot happen, so there is no solution for this equation. The next problem is sine of theta over 2 minus 1 equals 0. The pattern of problem is slightly different because the angle is half angle. Let's solve for sine of theta over 2, then that becomes 1. In this case, what we want to do first is find the solution with the half angle, theta over 2, and then we will multiply by 2 on both sides to get the answer for the angle theta. Let's go back to this equation. The sine value became 1, so we want to identify the angle values whose sine value becomes 1. Between 0 and 2 pi, we have only one solution. When the angle value is pi over 2, the sine value becomes 1. So for step 1, the answer will be theta over 2 equals pi over 2 plus 2 pi k. Step 2 is generalizing the answer. We have to get the answer for theta, so we multiply by 2 on both sides. Let's do that. 2 times theta over 2 equals 2 times pi over 2 plus 2 pi k. So these two will cancel each other. So theta equals, if we multiply these two, then we get pi plus 2 times 2 will make 4. So 4 pi k. If your question asks you about the solution in the interval (0 and 2 pi), then there will be only one answer, that is pi, when k equals 0. If you put k equals 1, then it'll become 4 pi. 4 pi plus pi will be 5 pi, and so on. So that'll not be in the interval 0 and 2 pi. Two times cosine of 3 theta equals 1. As we did, we will solve for cosine of 3 theta. Then cosine of 3 theta will become 1 over 2. Firstly, that is greater than 0. We will take 2 steps as we did before. We will solve for 3 theta. Again, 30, 60, 90 degree triangle is involved. And we locate the angle either in the first quadrant or third quadrant because x values are positive in the first and fourth quadrant. So this is pi over 3 and this is another pi over 3. So one answer is pi over 3 and the other answer is 5 pi over 3 from 6 pi over 3 minus pi over 3. So we can say that 3 theta equals pi over 3 plus 2 pi k, or 5 pi over 3 plus 2 pi k. That is the solution for 3 pi. Second step is solving for theta. So we have to multiply by 1/3 on both sides. So when we multiply 1/3 on the left side, we will get theta. So that will be theta equals 1 over 3 times pi over 3 plus 2 pi k, or 1/3 times 5 pi over 3 plus 2 pi k. So that means theta equals, we distribute, then that'll be pi over 9 plus 2 pi k over 3, or 5 pi over 9 plus 2 pi k over 3. For a general solution, we came up with these two solutions. But let's suppose that the problem is given differently with the limit with the angle. If the problem asks you to find the solutions in the interval 0 from 0 to 2 pi, then we have to work with k. So we will start to put k equals 0, 1, 2, and k equals 3. So k equals 0, then when you plug in k equals 0 here and here, these two terms will vanish. So we have an answer. Theta equals pi over 9, or 5 pi over 9. If k equals 1, then we just use these two. Theta equals pi over 9 plus 2 pi over 3, or 5 pi over 9 plus 2 pi over 3. What I did was we replaced k by 1. So I added 2 pi over 3 for the first one and 2 pi over for the first and second one. Then we have to think about the common denominator. For this one, common denominator 9 will be made by multiplying by 3 to the numerator and denominator, so 6 pi over 9. So it becomes pi over 9 plus 6 pi over 9, or 5 pi over 9 plus 6 pi over 9. So theta equals 7 pi over 9, or 11 pi over 9. So currently we are getting 4 answers. Let's consider what happens when k equals 2. We will replace k by 2. Then 2 times 2 will give us 4 pi over 3. Let's do that. Theta equals pi over 9 plus 2 times 2 will make 4, so 4 pi over 3, or 9 pi over 5 pi over 9 plus 4 pi over 3. So theta equals pi over 9 plus, if we think about the common denominator, then that will become 12 pi over 9. So that becomes 13 pi over 9. For this one, theta equals 5 pi over 9 plus 12 pi over 9. I just multiplied the 3 to the numerator and denominator to get 12 pi over 9. Then that equals 17 pi over 9. So we have another 2 solutions. What you have to notice here is the solution must stay between 0 and 2 pi. We are thinking about the denominator 9, so we have to think about 18 pi over 9. When we think about k equals 2, one of the solution became 17 pi over 9, which is very close to 18 pi over 9. So what you can imagine is if you put k equals 3, then probably it'll be off that range, but who knows? So we will just do it to be safe and to make sure that those angles are not in that range. So k equals 3, so this one will be 6 pi over 3, right? K equals 3, then 2 pi k over 3 will become 2 pi times 3 over 3. Those two will cancel each other, so we are getting 2 pi. And we know that theta equals pi over 9 plus 2 pi, and 5 pi over 9 plus 2 pi. Here, if you look at this, then what I said was this fraction will be 2 pi, this fraction will be 2 pi. So I added 2 pi here. Then obviously this is greater than 2 pi, and this will be greater than 2 pi because positive numbers are added. So when k equals 3, angles are not in the range we are considering. The interval 0 to 2 pi. So the final answer for this remark is pi over 9 and 5 pi over 9 and 7 pi over 9, 11 pi over 9, 13 pi over 9, 17 pi over 9. There are many answers. Though the answers are about the problem in the remark. But if the problem is about finding all solutions, then this is the answer. Let's do the next problem. The next problem is 5 sine squared of theta minus 21 sine of theta plus 4 equals 0. The problem will not be neat. So the problem is asking you to round to 3 decimal places. This is involved to the quadratic equation. Let x equals sine of theta to convert that into the more familiar form of the equation. The equation becomes 5 times x squared minus 21 sine of x is x plus 4 equals 0. 5 is a prime number. The only thing we can do is 5 times 1. And for 4, it can be 2 times 2. But if you cross multiply, then it'll be 10 and 2, so it'll become 12. So, but the number in front of x is minus 21. So I will organize that like 1 times 4. Then when I multiply, cross multiply, this one will be 20. And this one will be 1. If we just add them up, then we will get 21. But we want to make the number in front of x, which is minus 21. So to do that, we have to put minus for both, and then transfer that to the adjacent number. When we put minus to both minus 1 and minus 4, when we multiply them, that becomes 4. So after you do this, this one becomes like this. 5x minus 1 times x minus 4 equals 0. So two numbers are multiplied, so we get 5x minus 1 equals 0, or x minus 4 equals 0. We have to solve for x, then we get 5x equals 1, so x equals 1/5. For this case, x equals 4. Then we get the sine values. The first one indicate sine of theta equals 1 over 5. The second one is sine of theta equals 4. This case is impossible because the maximum value of sine is 1. So for this case, no solution. The solution came out from sine of theta equals 1 over 5. To do that, we have to solve the equation, we have to use calculator. That is greater than 0. So what we want to do is we want to use the calculator to get the reference angle of theta. Reference angle of theta is sine inverse of 1 over 5. What's happening here is the range of sine inverse function is minus pi over 2 to pi over 2. If you use your calculator, then the calculator answer will be the angle in the first quadrant. So that is an acute angle, and that will become a reference angle because sine is positive in the first and second quadrant. So for this reference angle is sine inverse of 1/5, and this reference angle is sine inverse of 1 over 5. So if you use your calculator, then it will give you approximately 0.201 because we have to round to 3 decimal places. So for this one is 0.201, and for this one you have to subtract pi minus sine inverse of 1/5 is approximately 2.940. You have to use your calculator. And then we have to generalize. One solution is 0.201 plus 2 pi k. The other answer is 2.940 plus 2 pi k. There are 2 answers. In this problem, we want to solve the equation 2 times cosine squared of theta minus sine of theta equals 1. Cosine and sine are combined in this equation. So we want to convert the equation into the sine-related equation. We can do that by using Pythagorean identity. Pythagorean identity is cosine squared of theta plus sine squared of theta equals 1. Then we will solve for cosine squared of theta to get 1 minus sine squared of theta. After we do that, we will replace cosine squared of theta by 1 minus sine squared of theta. Let's do that. Cosine 2 times cosine squared of theta is 1 minus sine squared of theta minus sine of theta equals 1. So we can distribute that, then that is 2 minus 2 sine squared of theta minus sine of theta equals 1. We subtract 1 on both sides, then the left side becomes 1 minus 2 sine squared of theta minus sine of theta equals 0. Let's rearrange the terms. Then we get minus 2 sine squared of theta minus sine of theta plus 1 equals 0. We multiply by minus 1 on both sides. Then we get 2 times sine squared of theta plus sine of theta minus 1 equals 0. Instead of replacing sine of theta by x, we will just directly factor this quadratic equation. I will put 1 times 2 here. 1 times 2 will make 2, and 1 times 1 will make 1. If we cross multiply, then it'll give us 2 for the first one and 1 for the next one. Our purpose of doing this is when we add vertically, we have to get 1, the number in front of sine of x, first degree term. The final answer is, the consequence is 1 when we add them up. The only way that can happen is when we put minus sign in front of 1. And then we will transfer that to here. Then now 1 times minus 1 will make minus 1. That's perfect. We will combine those horizontally. Then we get, this time instead of x, we have to write sine of theta, sine of theta. 1 times sine of theta is sine of theta, so factoring form will be sine of theta plus 1 times 2 times sine of theta minus 1 equals 0. So we have two equations. One is sine of theta plus 1 equals 0, or 2 times sine of theta minus 1 equals 0. So for the first one, we have sine of theta equals minus 1. For the second one, we have 2 times sine of theta equals 1. So sine of theta equals 1 over 2. We have two equations. One is sine of theta equals minus 1, and the other is sine of theta equals 1 over 2. We will solve both equations. The first one is sine of theta equals minus 1. Minus 1 is the minimum number, minimum value for the sine function. So we have to use the graph. This is 2 pi, this is negative 1, this is pi, this is 3 pi over 2. So we have only one solution between 0 and 2 pi. So when we write the general solution, that'll be 3 pi over 2 plus 2 pi k, when k is an integer. The second one is sine of theta equals 1 over 2. The first thing we can notice is that the sine value is positive. So that'll be first or second quadrant because y values are positive. And other important thing is the reference triangle associated to that is 30, 60, 90 degree triangle. One is opposite and two is hypotenuse. One is opposite to pi over 6. So pi over 6 is the reference angle of theta. Angle should be the angle in the first and second quadrant with the reference angle pi over 6. This is 6 pi over 6. So one solution is pi over 6 and the other solution is 5 pi over 6. So we have two solutions. Theta equals pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. Altogether, we have three solutions. So final answer is theta equals 3 pi over 2 plus 2 pi k and 6 pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k.